So this is 2012. I know it's quite odd, but we still have questions like these even today. So the third term of a GP of positive terms is 18 and the fifth term is 162. Find the common ratio and the first term. So let's write the data down. Remember, it's all about simultaneous equations here. So we are taught that the third term of a GP is equal to 18 and the fifth term is 162. And remember, this is a GP, so the nth term is given by AR to the power n minus 1. So now find the common ratio and the first term. So we can get the first equation from here and the second equation from there and solve the two equations simultaneously to solve for A, which is the first term, and R, which is the common ratio. So we can say T sub 3 is equal to A R to the power 3 minus 1. But we know that T sub 3 is 18, so you have 18 there. A to the power, this minus this is 2. So this is our equation 1. For our equation 2, we can say T sub 5 is equal to A R to the power 5 minus 1. And we know that our T sub 5 is 162. So this would be AR to the power, this minus this will be a 4. So now we can solve these two equations simultaneously. Remember, the easiest way of solving such kinds of equations is by making A the subject. Yes, you can make R the subject, but that's a lot of work. It's much easier when you simply make A the subject because it has no power. You simply divide both sides by that and you are done. So you have 18, over R squared. And then I can simply substitute this in the other equation. We have 162 is equal to, where we have an A, we can substitute 18 over R squared multiplied by that. So now this would be 162 is equal to, remember what happens to the powers when you're dividing, because this is like r to the power 4 divided by r squared. This would be 18r squared like this. So that's like saying 4 minus 2. So that gives us this. So to solve for r, you can simply divide both sides by 18. And then we can say r squared is equal to 162 over 18. And because I don't have my calculator, I will reduce this so that I have a 2 there, gives me a 9. Then a 2 there, this is an 8. A 2 there, 1. So if I want, I can divide through by 9 and get a 9 and then find the square root of 9. Or I can just introduce the square root right there and then and say the square root of this is 9 and the square root of this is 3. Divide the two and get the answer. But I think the easiest would be to divide this into this. So this into 9 into 81 is 9. Then to find the value of r, you introduce the square root on both sides. Let me just read the question to see if r can be negative or positive. So the third term of a GP of positive terms. So all the terms are positive. So that means you just get the positive square root here. No need to put plus or minus. So the square root of 9 is 3. And you have solved for r. And then remember, the question wants you to find a and r. So we have found our r, this is 3. So to find our a, you can just use this one. I think it's much easier than the other one. The numbers are bigger there and you have a bigger power. So you have 18 over our r is 3, so you can say 3 squared. So we have 18, 3 squared is 9. Then 9 into 18, this will be a 2, and you are done for the first part. Next, we have this one which says write an expression for the nth term of the progression. So in this case, you simply use this formula. Remember, this is a GP, so the nth term is given by ar to the power n minus 1. So since they want the nth term, you don't put anything on n, but you know what the a is and you know what the r is. So you can substitute everything else but n. So our a is 2. Let me put it in brackets. Our r is 3. Our n is unknown. So I don't think you can simplify this any further. Maybe if you separate these, but I think you can just leave it like this, or you can say 2 multiplied by 3 to the power n minus 1, and you are done. And then find the sum of the first 8 terms of the progression. So remember, the sum of the nth term of a GP is given by a 1 minus r to the power n, everything over 1 minus r. So we have another version of this, but I prefer this. You can in mathematics, they can even specify when to use this, when to use the other one. But at the end of the day, they are equally the same, except that you get to do more work when you interchange the two. So our a here is 2. So find the sum of the first 8 terms. So our n is 8. Our a is 2. Then you have 1 minus, our r is 3, our n is 8, everything over 1 minus our r, which is 3 again. So now you have 2, 1 minus 3 to the power 8. This is quite a number for someone who has no calculator, but I believe you can finish it up from here. So this minus this is negative 2. So you can cancel these 2 out. Then you have a negative. This negative, because negative 2 into negative 2 is negative 1. So you have this, which will simplify to this times this will be negative 1. This times this will be positive 3 to the power 8. So now you can just punch this on your calculator. I'll just leave it here for you to finish. And I think this marks the end of part A. So we can try to move on to part B. Find the geometric mean of 1 over 64 and 1 over 16. So for the geometric mean, we usually use 3 letters. So when you have letters like A, B, and C, which are 3 consecutive terms of a GP, then the geometric mean, which is the B, is given by the square root of the product of the other 2 numbers, A and B, like that. So in this case, the geometric mean of these 2 numbers will be B is equal to the square root of their product. So 1 over 64 multiplied by 1 over 16. So you don't need to multiply these numbers because that would be a lot of work. You are making your numbers too big to work with. So you can just separate them and say the square root of 64 multiplied by the square root of 16. Remember, the square root of a times b is the same as the square root of a multiplied by the square root of b. Yes. So the square root of 1 over 64 is 1 over, remember the square root of 64 is 8. Then the square root of 16 is 4. So that means you have 1 times 1 is 1, this times this is 32. And that's it. This is the geometric mean of these two numbers. So now, part C is saying, find the number of turns of the AP, this one, that must be taken for the sum to be equal to 444. So we have the first term as 15, and then the common difference, you simply subtract this from the next number or this from the next number. The answer will still be the same. So 9 minus 15 is 4, or 23 minus 19 is still 4. And then we want to find this. The sum of the nth term is 440, but the n is unknown. So you can use the equation which has all these things and solve for n. So that equation is the sum formula for an AP, which is given by S sub n is equal to n over 2, and then 2a plus n minus 1 d. So our n sub n is 444. Our n is unknown, and then our a is 15, plus our n is still unknown, our d is 4. So now we have 444. Maybe we should multiply both sides by 2 to get rid of the fraction. Okay, maybe later. So this times this will be 30, and then this will be that. So maybe we can expand this, and we may not even need to cross multiply or to multiply both sides by 2 because these numbers are all even. So you can say 444 is equal to, we expand this, n over 2 multiplied by 30, this will be 15n because these two will go into 30 15 times. And then this times this will be n over 2 multiplied by n minus 1, 4. And then you can do this so that you have 2n, n minus 1 like this. So now we have 444 is equal to 15n. When you expand this, you have 2n squared minus 2n. Like this, and then we can subtract these two guys. So we have 444 is equal to 2n squared. 15 minus 2 is positive 13n. So to minimize the number of negative numbers, I'll just take the 444 this side. Now these are quite big. Okay, so now I don't think using the factorization method will be a very good idea here because the numbers are too big. Even suspecting a mistake. Anyway, let's use the formula. So using the formula, n is equal to negative b plus or minus the square root of b squared minus 4ac everything over 2a. So our n will be, our b is 13, so this will be negative 13 plus or minus the square root of 13 squared minus 4. Our A is 2. Our C is negative 444, which is quite a number. Then our A again is 2. So now we have negative 13 plus or minus 13 squared is it 169. And then for this, I may need, okay, so using my calculator, this times this times this is not even a calculator, it's a phone. 3552. Then everything under the square root here. And then 2 multiplied by 2 will be a 4. Then we have negative 13 plus or minus. We can add these. Let me just be a little bit lazy. So we have this plus 13 squared. 13 squared, is it? Okay, so we have this as the total. Doesn't make sense. Oh yeah, this is, yes, that's correct. So we have 3721 everything over 4, and then the square root of 3721, this is why I don't like calculator work. 3721, this is 61. So we have this plus or minus 61 over 4. So when you separate, you have this plus 61 over 4 or negative 31 minus 61 over 4. So now this plus this, that is 3 plus 1, this would be a 4. This plus this is 7. Yeah, yes. Then over this, of course, this is a negative number. And then you can just reduce the fraction. So 4 into 7 here is 1. Remainder, of course, we can reduce it to this. And then you can either leave it like this or write it in fraction form as mixed fraction form, by the way. 2 into that's a 1, remainder 1. 2 into 17, this is an 18, 1 over 2. Of course, this is a negative. And then this side, 61 minus 13, 11 minus 3 will be an 8. Then 5 minus 1 will be 4. So this is like 48 over 4. Luckily, this is a whole number. So this into this, we have a 1. This into that, we have a 2. So these are the two possible values of n. But of course, you don't expect your n to be a negative number. Why? Let me just read the question again. Find the number of terms of the AP. That must be taken for the sum to be equal to that. So of course, you don't expect the number of terms to be a negative number. So this guy will be rejected. We should have rejected it earlier. So this is the correct answer. And we are done.